Hi, I'm Will Creighton, and today I want to talk about automatically generated documentation, or autodocs. Let's start with an example. Let's say we're learning the Rust programming language, and we're trying to use their resizable array data type, or vector. We have a line of code like this. And our goal is to add 5 onto the end of v. So how can I do that? Well, let's say I know that this operation is called append in Python, so let's search for that first. I can go to Google and type Rust vector append. There are several results. The first one is to the standard library, which has append. Let's take a look. This takes as input a vector as the other type, so this doesn't seem exactly what we're looking for. So we can keep searching. We're already in the documentation. Might as well scroll down. There's drain, clear, len, is empty, split off, resize with, leak, and so on. There's a lot of methods in here. We could keep going. There's, I think, hundreds of methods, in fact, in this page. But eventually, we would stumble upon the thing that we want, which is called push in Rust. So push actually appends the element to the back of the collection, which we would just have to skim for. But this raises the question, did our search for this method need to be that hard? Could this web page have presented the API information in a way that makes the search easier? And in fact, the Rust docs already have a few features that can help. So the left sidebar provides this alphabetically sorted list of method names, which we can skim a little more quickly. And we can also toggle the method details to see a more condensed view of the methods with this plus button. And if we look beyond Rust, we can see even more documentation techniques. So for example, this is the Haskell documentation for its list data type, and they have a hierarchical structure where the methods are grouped by their category of what sort of semantics they have, like the set of methods that deal with searching on lists. And they also have this pop-out synopsis box that contains a little overview of all of the methods with just their names and type signatures. However, not all automatic documentation is so friendly. Out of 9 different languages I surveyed, only 3 contain any kind of method summary, and only 2 contained a list-specific hierarchical organization. And so the point is that nobody agrees on exactly how to generate documentation for something like arrays, but it's clear that certain features would be helpful in improving documentation usability. And so in this talk, my goal is to give a more general framework for thinking about the design of documentation generation. Documentation is generally for APIs, and APIs have many kinds of constructs, like modules, traits, structs, and methods, and so on. And all of these constructs are related to each other. A module contains this, a method returns this type, and so on. And when we generate documentation, this is essentially an information visualization problem. How do we organize and present API information? Techniques from InfoVis help bring structure to this messy network. We can impose hierarchy and provide a visual layout that promotes hierarchical search. We can restructure layouts to focus on different kinds of information. And we can combine visualization with automated search to reduce the amount of reading needed. And so I'll give you a more formal model to help make these ideas concrete. Think about an API like a big database of information. The main goal of generated documentation is to provide access into this database, where developers try to look up individual rows. A developer doesn't know exactly what they're looking for, but they have a lead, which is a piece of information about the desired construct. A developer may have many different kinds of leads, like the struct, I know it's a method on vectors. Or it could be the return type, I'm looking for a method that returns an option. Or it could just be the module, I know I'm looking for something in the standard library. Somehow the developer would like to use one or all of these leads in order to locate the one method that they need. Now, the central question under this model is then, how can generated documentation help developers act on their leads? And I think there are two main ways a developer can use a lead. The first is skimming. You generate a large set of information, like looking up all of the methods on a particular class. Then you visually scan the information for the target construct, and you mentally compare each method's name and description against the idea in your head to see which one seems right. And the alternative is searching, where you encode a lead into a query that you run through a search engine. So an algorithm mechanically compares your lead against the database rows. Now, the value of this model is that we can combine these methods with leads to suggest a matrix of design principles for documentation. So for example, just looking at Rust docs, I would say it's relatively easy to search for structs and methods. And it's somewhat easy to skim for method names or type signatures, but it's pretty hard to skim for different structs or particular mutabilities. And you can't easily search based on type signatures. So how would we improve this state? One idea is to design more information-dense visualizations to make method information more skimmable. So here's a prototype that I mocked up for Rust showing the vector methods. First, we impose hierarchy by using relevant criteria like mutability to group methods and put them in separate columns. Then, we only show selected details of the methods, like the type signature or the name. And then you carefully align the information between methods to promote skimming down a column, which reduces mental parsing effort. All of these contribute to making these methods more skimmable. Now, another idea is we could make information more searchable. So for example, I think every typed language, you should be able to search by types. Like for example, here, we could try and find a push method by searching for alpha, arrow, alpha list, which in typed polymorphic kind of terminology is, given a list of any type and a value of that type, give me back a list, which hopefully has that element pushed in. And you can even see at the bottom here, it gives us back cons, which is the specific function in Haskell we might be looking for. And so this is a great tool, Hoogle, and it raises the question, why doesn't everybody have this? This is clearly a valuable thing to allow developers to search on type-based leads. And so to wrap up, I think the PL/HCI community should investigate documentation generation. Autodocs are critical to developers in many languages, but have few established design principles. And we can use frameworks like the one I'm proposing to identify areas of inquiry. I mean, just look how big this research zone is, even given how simple this model is. So I would love to hear any ideas about related tools or theories, what other leads y'all would put onto this list, and then any other comments or questions. Thank you.